Okay guys, so we are going to be solving part 2 of our logarithmic and exponential equations. So go ahead and take a look at my question right here. So how do I know when an equation is solved? Remember, an equation is going to be solved when x is isolated. And we are not really using the calculator, we're just getting everything in calculator ready form. Also, at the bottom of my screen, remember when you are solving and you are looking for an answer, this can be anything. That's all domain, all real numbers. This, remember, that can only be a positive answer. And remember, that x is going to appear as the argument. That is why the domain for x here is going to be 0 to infinity. But there are a couple of extra things I want to talk about. Of course there is. There always is. Let's go ahead and talk about this scenario right here with regards to domain. What if I had log base b of x minus 4 and this equals something? We're just really worried about what the possible domain would be for the argument. Remember, it cannot be negative, so it has to be greater than 0. So x has to be greater than 4. So my possible answers here are going to be from 4 to infinity. And if you remember, if I graph that, I would have a vertical asymptote of x equals 4. So all of that will make sense why the domain is restricted. Okay, let's go ahead and talk about how we're going to solve for x for some of this stuff using some mental math. I want to show you guys this question right here. So remember, our whole goal is to find having a log on both sides just equal to a single log. So I don't even care what the log is, what the base is. Let's just say it's log base b of 45. And this is going to equal x log base b of 3 plus log base b of 25. So as you see here, there's not really a constant or anything that would trip up having just a single log here and a single log here. So what I'm going to do is I'm going to put this factor back as an exponent. I'm going to go ahead and clean this up. That x is going to turn into an exponent. Remember, the addition means multiplication. Here we go. We get to drop the logs. So the real reason why I'm showing you this is because I'm really lazy and I don't want to get a calculator for that. So I want to show you guys a couple of things. So without using a calculator, we're going to be able to solve this because if you remember, 9 times 5 is 45. And we're squaring that, which means we're going to have a couple of 9s here and a couple of 5s there. And on this side, 25 is 5 times 5. So if I have 2 5s here and 2 5s here, I don't have to go grab a calculator. These are just going to cancel out, which means I'm going to have 81 equals 3 to the x. So you guys know that 81 is a power of 3 to the 4th power. So I just wanted to show you guys a way that we were able to reason through that without a calculator. Okay. So let's go ahead and take a look at a couple of examples here. So we are solving exponents that cannot be written in the same base. This is the base of e. There is no way I can rewrite a 72 with a base of e. So we're going to take the log. And you need to take the log of whatever is the exponent. The exponent, whatever the base of the exponent is. The base is e. So I want to take the natural log of both sides. So what this is going to look like is this. Remember, it's an equation. if I take the log of the left side, I have to do the same exact thing to the right side. And remember your log properties. The base is e here, which means that's going to get wiped out completely. So I'm able to solve for x. X is completely isolated. X is going to equal the natural log of 72. X is by itself. We can go ahead and box that in because that is solved correctly and able to be entered on the calculator. Let's take a look at number 2. For number 2, you have to isolate the exponent. So this plus 5, it just needs to get pushed over to the other side. So this is going to be e to the x equals 55. I cannot rewrite that with a base of e, so you're going to have to take the log. And it's a base of e, so we're taking the natural log because the natural log of e is going to cancel out to a 1. So x equals ln of 55, or natural log of 55. That's calculator ready. So, kind of a lower level of solving these, what you need to remember is this property right here. You're going to be using that a lot when we go to solve for exponentials where we cannot write in the same base. And remember, we had a base of e here. That's why I'm writing the natural log, not some regular log with a different base. All right, let's take a look at this one. So on this example right here, we're going to do a couple of different things. There's actually a couple of different ways you can write this. We're going to change this to common log form. And remember, common log form is usually calculator ready when the base is not a ln or the common log, which is base 10. Okay, so my e is not isolated. It's being multiplied by a 4. So we have to divide both sides by 4 or multiply by 1/4. So what we have is e to the 2x equals 5 to the 4th. So again, I cannot rewrite this as a base of e, so I'm forced to take the natural log. So this is going to be natural log of e to the 2x equals the natural log of 5/4. So from here, I am going to be able to drop the logs because the log, this is going to cancel out. So I have 2 to the x equals ln of 5/4. And I misspoke when I said drop the logs. We're just going to cancel that out to a 1. Okay, this is not isolated here. So we're going to have a couple of options. We could divide by 2, of course, but what we're going to do is we're going to multiply both sides by a half, because when we multiply both sides by a half, you've got your power property right here. All right, so here's what I mean when you have a couple of different ways to find the answer. The first thing I can do is I can put this back to the log. So the 1/2 I'm going to put back as a power. So x is going to equal ln of 5 to the 1/2 over 4 to the 1/2. Now I really hope you guys see that's the same as this, which simplifies to a 2. So what we are really going to have here is x to the ln of 5 to the 1/2 over 2. That's acceptable. We like that. One more way that you need to write this log is you can write it in radical form. So this could be the square root of 5 divided by 2. That's perfectly acceptable also. So it is a natural log form, but let's just say that I wanted it in common log form for some weird reason. If you need it to be in a different log format, then you have to use change of base. So this would be, let's just take the common log like the instructions, right? The common log of square root of 5 divided by the common log of 2. So we would do actual division here. Okay, this next one here. I'm going to go through this pretty quick. It's not going to be something that really should be on our radar, but when you guys see something like this, when you see a 2x and then half of that right there, make sure you check to see if it's factorable. Pretend it looked just like that with regular x's. That is certainly factorable, which means this is factorable. So this is going to turn in to e, see there's two x's there, I split them up. And we have a positive 2, but we need it to equal a negative 3. So that's minus 2 minus 1. So E is going to equal a positive 2 and a positive 1. I'm sorry, not E. It's the x. So e to the single x, e to the single x. So what we're going to do here is we are now going to solve for the single x. So again, I split my e's up. I have e to the x here and e to the x here. So e to the x is going to equal a positive 2 or a 1. So now let's go ahead and solve for x. So remember, I need to take the natural log of both sides. Let me go ahead and split this up into two problems. So when I take the natural log, those are going to cancel out. So one of my possible answers is x is going to equal the natural log of 2. However, here I'm going to have a plain answer. Remember, I have an answer of 1 here. Anything to the 0 power is 1. So x is also going to equal 0. So that's going to be our two answers for this example. All right, so now we're going to start solving things without the word log. If it doesn't have the word log, then we need to check to see if we can write it as the same base. I could not make 10 a base of 2, so I'm going to have to take a log. So you're going to have a log of whatever base you're looking, the base that is in the problem. So I have a log of 2, or I'm sorry, I have a base of 2, then my base is going to be 2 when I take the log. So here's what this is going to look like. I'm going to take log base 2 of both sides. Remember, it's an equation. What you do to one side, you have to do to the other side. So I'm taking log base 2 of 2x equals log base 2 of 10. There's your 1 right there. Remember, when these two are the same, that cancels out to a 1. Your x drops down. So x is going to equal log base 2 of 10. That's it. That's ready to go. X is solved. But remember, sometimes we have old technology where we cannot take log base of anything else except a natural log or a common log. Let's rewrite this in natural log form. Whenever you're told to write it in a certain way, that's a cue for a change of base. So what is going to happen here is x is really going to equal the natural log of 10 divided by the natural log of 2. So according to these directions, that's going to be our final answer for problem 5. Okay. Let's take a look at the next one. So here we're trying to solve for x, and this is in log form. If this is in log form, then we put it back in the other form, which is exponential form. Remember, the base is e, so we have e to the third equals x. Is x isolated? It is. So sometimes when it's written in log form, sometimes it's a little bit easier to solve. That's it. That's the answer for x. Okay, let's take a look at the next example. So for the next example, it's in log form, so obviously I'm going to put it back in exponential form, but your log has to be completely isolated. I have to get rid of that 5. I have to get rid of that 2. So I'm going to get rid of the 5 first. So 2 ln of x is going to equal a negative 1, which is okay. That's an exponent, so it can be negative. Just remember that number. It can't be negative. but we need to get rid of this too. So ln of x is going to equal a negative 1/2. Put back in log form or exponential form. Remember the base is e. So e to the negative 1/2 is going to equal x. But before I box that in, you should have recognized something. And what you should have recognized is that's a negative exponent. You cannot turn in things with a negative exponent. It can have a negative answer. You just have to rewrite it in proper form. So we are not boxing that in. We are going to rationalize this. So the first thing I need to do is make it positive. There we go. The next thing I need to do is get rid of that fraction. So remember, we have to make it positive. And now we have to get rid of the fraction exponent. All right, so I want that to be a whole number right there. So I have a half, which means if I add one more half to it, it's going to be a whole. So we're going to multiply both the top and bottom by e to the half. So now what we're going to get is e to the 1/2 on top divided by just plain e on the bottom, because a half plus a half is a whole. And this is proper form for the exponent, and this is what we need to box in. Okay, let's take a look at the very last one. This is going to be it, and then I'm going to ask you to do one on your own. So we're going to have to do a couple of steps here, and you'll see this once we take the log. So this is as involved as it's going to get for us in this class. There is not the word log written, so if the word log isn't written, then I want to try to rewrite that as that base, which is impossible. So we're going to take the log of both sides. The base is 2, so we're going to take log base 2 of both sides. So I'm going to recopy what we're taking from the left side and recopy what we're taking from the right side. So remember, this is going to cancel out right here. So on the left side, I am going to end up with x minus 1 equals log base 2 of 7. X is not isolated, so we're going to add 1 to both sides. Just like that previous example where we had a negative exponent, that was in proper form and we had to fix it. Same here. This is not really proper form. X is equaling a binomial here. We want to rewrite this as a single log. The whole entire answer needs to be a single log. So you're going to have to use your exponent properties. I'm sorry, not your exponent, your log properties. Remember, log base b of b equals a 1. That's how we were able to knock all this stuff out at the beginning. That's a 1 right there. So this form of 1, I need to write it in this format. Remember, we're dealing with base 2. So what I'm going to do is I'm going to recopy x. I'm going to recopy the first log because it's already in log form. But I'm not writing a 1. I'm using my log properties to write a form of 1. So this is log base 2 of 2. But remember, you need to have it in single log form. You got to still use your log properties and go ahead and multiply the 7 and the 2. So x does not equal log base 2, 7 plus 1. X equals log base 2 of 14. Single log, x is isolated. This is new technology. Ready? Old technology, you would have to use change of base. This is fine. This is proper form. Okay, so I'm going to ask you to do one just like I did on your own. You're going to show this to me in class. And then that's it. I'm not going to work that out. I'm not going to show you the answer. You're going to do that on your own.